Hello, students, and welcome to April 9th. And we're going to start today with our Do Now, where we celebrate National Unicorn Day. Our objective will be to begin solving equations, and our essential questions are, how do I solve an equation and what is an inverse operation? So today I would like you to complete the Do Now, the work page, the exit ticket, and make sure that you show your work to me. If you don't finish it in class, you can finish it at homework, but you do have to show me what you have completed before class is over. So I want you to have a restful week, as I intend to do. And remember, Q3 is over, so no more work can be submitted for Q3. Do your best in fourth quarter. Now we'll come back to our exit ticket. But first, our Do Now. Today is National Unicorn Day. Why are people so fascinated with unicorns? Why do we think they are magical or fun? Or what fictional fun ideas or fictional animals make you smile? So spend a minute and write a couple sentences there. So now we're going to solve equations. And before we do that, I want us to think about inverse operations. Inverse are like opposite operations. And the inverse of addition is subtraction, and the inverse of subtraction is addition. The inverse of multiplication is division, and the inverse of division is multiplication. So let's take a look at these, and we want to think about these in terms of how many terms there are. So x divided by 4 plus 2 equals 10. So there's x divided by 4 is a term, then we have positive 2, and we have a 10. In the middle, we have an equal sign. Super important. Never forget that whatever you do to one side of an equation or an inequality, you must do to the other side. So first thing I want to do is isolate or make by itself the term with, or that contains, the x. And once I've isolated the term with x, then I can isolate the x. So the term with x is right here. It is x divided by 4. Well, in order to isolate that, I'm going to have to get rid of this 2. So I have to use inverse operations. So if 2 is being added to x divided by 4, then I'll subtract 2 from each side. Whatever I do to one side, I do to the other. So the positive 2 and negative 2 cancel, and I'm left with x divided by 4 equals 8. Now, I still need to isolate this x. So what I will do is the inverse of whatever is happening to x. So first I say, what is happening to x? It's being divided by 4. The opposite of division is multiplication. So I will multiply by 4, but whatever I do to one side, I have to do to the other. So 4 over 4 cancels, it becomes 1. And now our x equals 8 times 4, which is 32. So if we substitute 32 for x and solve this, our answer will check. So number 2, what's happening? We've got the term 9x and then 7 is being subtracted. So first I'll add 7 to both sides. And that means 9x equals 0. Now x is being multiplied by 9. So now I'll divide by 9. And I'll divide the right side by 9, and that means that x equals 0, because 0 in the numerator means the whole term is 0. Number 3, first I need to get rid of this fraction by multiplying both sides by 3. Oops. So 3 divided by 3 equals 1, and now I have 9 plus x equals 2 times 3, which is 6. Now 9 is being added to x, so I'm going to subtract 9 from both sides. Positive 9 and negative 9 cancel, and x equals 6 minus 9. X equals negative 3. And in number 4, x minus 9 is negative 2. So I'm going to isolate x by adding 9 to both sides. Cancels here, and x equals 7. Negative 2 plus 9 are 7. And now I have 5x minus 42 equals 73. So I need to isolate 5x. So I'm going to add 42 to both sides of this equation. And now 5x equals 115. Now, x is being multiplied by 5, so I will now divide both sides by 5, and x will equal, 115 divided by 5. This is how you should be doing it. So 5 times 2 is 10, and there it is, 23. So let's move on to number 6. 3x minus 2 equals 29. So I'm going to isolate the 3x by adding 2 to both sides. Whatever I do to one side, I do to the other. And 3x equals 31. And now x is being multiplied by 3. So I'm going to divide by 3 on both sides. And x equals 31 divided by 3. We could make that 10 1/3, but in algebra, we usually keep in proper fractions. Number 7, 7 minus 3x equals 34. So I've got a negative 3x to isolate. What's happening to this negative 3x? 7 is being added to it. So I'm going to subtract 7 from both sides, which would give me negative 3x equals 27. And now I'll divide both sides by negative 3 so that I can isolate that x, and x equals, lost my color for some reason. There we go. X equals negative 9. Okay, so number 8. I have the term x divided by 2 plus 1 equals 9. So I want to isolate that x divided by 2, so I'll subtract 9 from both sides of the equation. That means I have x divided by 2 equals 8. And when I have x being divided by something, I want to multiply by the denominator. And whatever I do to one side, I do to the other. And now x equals 16. And number 9, I have 2x plus 10 equals negative 2. I want to isolate 2x. So I'm going to subtract 10 from both sides of this equation. And 2x equals negative 12. And now because x is being multiplied by 2, I'm going to divide both sides by 2. And x equals negative 6. Negative 12 divided by 2 is negative 6. And finally, number 10, the first thing I'm going to have to do is get rid of this denominator. So that's division. So I'm going to multiply both sides by 5. That cancels out the denominator, and I'm left with x minus 15 equals 4 times 5, which is 20. Now, what's happening to x? 15 is being subtracted, so I will add 15. And whatever I do to one side, I do to the other, and x equals 35. And that is a final answer. So let's complete our exit ticket about inverse operations. So let's describe those inverse operations. So the inverse operation to addition is subtraction. The inverse operation to subtraction is addition. The inverse operation to multiplication is division. And the inverse operation to division is multiplication. So good job. I hope you liked your introduction to equations. You're going to be doing a lot of those next year in algebra, and a lot of students think they're really fun. It's like a puzzle that you solve with everyone. So keep practicing. You're a great class. You're doing amazing things. I'm so proud of you. As you keep practicing, you'll be great.